go, baby, baby.
Let me in. I want to be closer to you. Open up your soul. Let me find that part of you, the part that nobody ever knew. Let me touch your mind. Oh, why don't you let me in? Let me be the first to ever touch your mind.
Hello and welcome to Let Me Touch Your Mind, the show where we try to get you to be something, do something, experience something, enjoy something. You know what I want you to enjoy right now? Science, because science can be awesome and fun. And it is Scintillating Science Monday. It's the first Monday of the month, and I've got a scientist here all lined up for you. I'd like to welcome the biggest brain that is not inside of a computer. I'd like to welcome Andrei Kurenkov. Hello.
Hello.
How are you?
Good. How are you?
I'm doing all right. So you are a PhD finalist?
Pre-candidate.
Pre-candidate.
Yeah.
Now, what is a pre-candidate? What does that mean?
So you need to pass some tests, basically,
okay.
to become a full-on candidate a few years in.
So when you say a full-on candidate, does that mean when you actually get your PhD, or what does it mean?
Well, yeah, PhD is a whole 6-year process. So about midway, you take some tests, and then you're officially kind of on your way.
Oh, okay.
Yeah, there's this thing called quals, which actually is a big portion of a lot of people's PhD.
Okay, so it's sort of like the halfway point between when you start to get your PhD and when you actually get it.
Yep.
Oh, okay. All righty. So your field of study is artificial intelligence, correct?
That's right. I work mostly with robots, computer vision and robotics, more specifically.
And how did you get into that? Or when did you first decide, or realize that, oh, I really like this area?
It's been a bit of a process to get here to Stanford. So I started out doing robotics in high school.
Oh, okay.
Which is true for a lot of people actually doing
right.
AI. I did FIRST Robotics, which is a great program.
Okay. What is FIRST Robotics?
FIRST Robotics is a high school competition where high school students build a robot to compete in kind of a sports-like game. And every year there's a different game. So it's like there's kind of basketball-like rules where you have a ball and your robot needs to fling it.
Okay.
And you get 6 weeks to build a robot from scratch.
So had you built robots before, or had you heard about it and thought, yeah, building a robot, that's what I want to do?
Yeah, no, actually, high school was when I started doing programming, doing robotics.
Okay.
And yeah, actually, my first couple of years, I wasn't sure what I wanted to do. So I did like graphic design, web design. And it was in my sophomore year or junior year of high school when I did Intro to Engineering and the Robotics Club, where I realized, well, this is what I want to do, is engineering, building stuff. That's what I'm good at.
Very nice. So then you went on to college and never looked back.
I went to college, but then I decided to do electrical engineering.
Oh, okay.
Because I got bored. Well, both my parents are software engineers, so I didn't want to just do CS. But then my sophomore year, I took Intro to AI, and I found it really interesting. So I ended up doing a bunch of research in robotics kind of my last 2 years. And after a bit of a break, so even after undergrad, I wasn't sure what I wanted to focus on. So I decided to work in software engineering for a bit. But I got bored, so I decided to go back to grad school, and now I'm back doing research in robotics.
Okay, so what specifically in robotics are you researching?
So I'm focusing on kind of manipulation in robotics. So basically being able to pick stuff up and use it, move it, manipulate it like humans can. A fun kind of fact about AI is everything that's easy for us is hard for computers.
Okay.
So what we're trying to do in AI and in robotics is kind of get computers to be able to do the stuff that is easy for us. So in my area, we're trying to get robots to be able to pick objects up consistently for any type of object without having, let's say, a 3D model of it.
I don't understand.
So you and I, if we see something lying on a table, just using our eyes, we can know how to pick it up. Right?
Okay.
For robotics, until recently, it's been very challenging to do that, having just like, let's say, a camera, video, stream and knowing how to pick it up. Instead, what people have done is they've had a full 3D model in the computer, like you would have in a video game, and then they can do like physics to it to figure out how to pick it up.
Got it. Okay.
But now we can do it just using an image without having the full 3D model, which usually you don't have, right, in the real world.
So when did it go from having to rely on that 3D, on having it already sort of encoded to being able to just look at it and go, oh, this must be this. I can handle it this way.
Yeah, actually just in the last couple of years. So as with a lot of subfields in AI, robotics have been benefiting from a lot of availability of data and compute and new machine learning techniques.
Okay.
So we can get computers to learn from a lot of data to kind of extract out patterns. So now what we can do is if we can show a robot many images of objects with annotated kind of grasps to say, this is how you should pick it up in this image, and you show it maybe 5,000 images, it can learn to generalize to any image.
Okay.
And then do that.
And so that just sounds like the most basic thing, just to be able to pick it up.
Exactly.
Once they pick it up, like, does it go to a different AI subset of what to do with it, or what happens after that?
Yeah, good question. So basically, it depends on the context. So you may be interested in picking and storing. So you may want to pick it up and then put it in a box. So like Amazon is presumably working on this, and getting robots to put stuff in the cardboard box that gets shipped off to your house. So then you would need to, after picking it up, do some more reasoning and more AI to know where to put it within a box and how to do it without colliding with other objects.
Okay.
Which we have some other algorithms for.
So your subset almost sort of deals with how to do an assembly line or a production line, yes. But can that be extrapolated to like someone who's lost the ability to use their limbs to be able to use that machine to pick and move things, or maybe even to move themselves?
Yeah, definitely. So I've actually spoken to people who are trying to, in the early stages, let's say, of commercializing something where you have an arm that you can sort of wear, and it can use this vision stuff to, let's say, if you need to pick up a bottle of pills from a cardboard and you can't reach it or it's hard to get to, you could ask this arm to do it for you. And so, yeah, you could definitely apply it to those contexts. Okay.
So when you talk about the pills, my first thought was, the other day I tried to open pills that had those child-proof foils on it. Can you I as a human have difficulty opening that. How do you train a machine to open something that that most people can't open?
Right. Well, that's a whole other area of difficulty.
Okay.
I guess that would be fine manipulation or dexterous manipulation. And actually, so there's been progress in surgical robotics to do actual surgery.
Okay.
Right? So there you need very fine skills. You need to do very precise incisions, very precise holding of tissue. And so far, all of that has been done through direct control. So doctors have learned how to use these surgical robots and control them. But increasingly, people are working on having robots kind of help out the doctors and take over some of the control. So probably what would happen in the hard to open child-proof bottle, it would be sort of you telling a robot to open it, and then it would kind of take care of some of the details of how to do that.
Okay. So let's talk about artificial intelligence sort of on a grander scale, because one of the things you see a lot in the media is that, you know, artificial intelligence is going to rule the world and it's going to solve all these problems, or conversely, it's going to create all these social problems because all of these people will be displaced who would normally have done the types of jobs that artificial intelligence would now take over, and there's no place for that to go. So do those ethical concerns come up in the work that you do?
Definitely, yeah. So I've actually started a blog called Skynet Today, which is a website. You can go skynettoday.com, which focuses on trying to convey to a more general audience kind of what is reasonable to worry about and what isn't. Okay. Because there's definitely a subset of things with AI where we should be concerned and we should be trying to make sure it doesn't go in a bad direction. So there's like, you can use AI algorithms to worsen issues of bias, right? Where if you, so
because the data is only as good as the data you put in.
Exactly. So you need to be careful not to just rely on data and forget that it can still kind of encode the bias that we already have. Or automation will lead to job loss. We kind of already know that this will happen. It has been happening already for decades, but AI is just going to continue that trend. So we need to be ready and we need to be aware of what to expect and how to deal with it. At the same time, there's a lot of concerns that are a little more sci-fi.
Like?
Well, this idea that we'll have suddenly...
The computer uprising, where they take over the world and become their slaves?
Exactly, where we get robots that suddenly control rockets or military robots or things that we see in Terminator, we see in popular movies, people like to talk about, some famous people, let's say, but that are not on the horizon as far as we can tell. So any serious scientist, and this has been pointed out by, the leaders of the field, that the people that are talking about scary sentient AI aren't AI scientists, right? They're not the people who really know what's going on. And if you're working with AI, you know that we are nowhere near anything that's sentient or human level, and we are just really automating very specific small things. Okay. Like being able to understand what you're saying, like Google speech recognition. The only thing that little AI program can do is that. So there's no sentience, there's no understanding involved. So I think there's definitely ethical concerns, and there's also an issue of separating out what's kind of real and what's more fiction that people still believe in.
Or hype even, because I see these people who say, oh, it's going to change the world and it's going to do all of this stuff. And then I think about my phone that crashes for no reason whatsoever. And I think maybe it's a bit overstated. So what are some of the limitations currently of artificial intelligence, or what are some of the things that are very difficult to breach, some chasms where you're just like, no matter how hard we try, we're not having any luck with this?
Well, in a sense, in some ways we've made a lot of progress, right?
Sure.
You can see a lot of new fancy things you can do, like good speech recognition, good translation. That all has come about for AI. But the only reason that has worked is that these are things where you can get a lot of data and you can just train the machine to recognize the patterns. So you can say, here's an input sentence in English, here's the correct translation in Chinese, here's 10 million sentences trained to do translation. But there's a lot of things where you cannot just easily get a whole bunch of data and have this kind of input-output format.
For example?
Here's a really timely example is self-driving cars, right? So there you can't just go and start with an algorithm that doesn't work and have it drive around and crash a bunch.
Yeah.
And that's true of most of robotics, actually.
Sure.
So there is a case where people have been saying, you'll have self-driving cars within a year for several years, and it's actually really difficult. And then there's many more, much more complicated cases, like, let's say, making decisions on how to best allocate your time. So let's say you want a smart calendar. Well, the calendar can't read your mind, right? There's a lot of nuance and there's a lot of flexibility that we all kind of can do as people that algorithms just aren't very good at right now.
Right. For example, if I say the word aeonium into my phone, it has no idea what I'm talking about. And I'm like, how do I train the phone to recognize this? I have no idea how to do that.
Yep.
So let's talk about, when talking about self-driving cars, don't self-driving cars, wouldn't they only sort of work if everyone was driving a self-driving car? Because when I'm out in the real world, I see all kinds of madness going on. I see people, just sort of careening in it. You see just madness, and you see people just sort of wandering into the streets and out of the streets, people changing lanes and if everyone were driving a self-driving car, then all the cars would follow the rules. But how do you train a self-driving car to deal with a world that is random?
Yep. That has humans doing crazy human stuff. Yes.
Unexpected things.
Yeah.
A dog runs in front of you, or
Right.
a homeless person pushes their shopping cart in front of you, or or an inexperienced driver stops when they should be going.
Yep. Yeah. So that's a big challenge of self-driving technology. And people kind of have different opinions on this. So Google, for instance, is trying to tackle this challenge. And it is conceivable that you can get self-driving technology to be able to handle all the craziness with a lot of work and a lot of investment.
But
that's still at least a decade away to be able to fully handle it. More likely what will happen is Rodney Brooks Rodney Brooks is an AI expert.
Okay.
He wrote some great predictions on basically we'll have staged kind of deployment. So it'll start with you have a self-driving car lane on the highway.
Okay.
And so you kind of partition off a little section that's a little less crazy that the self-driving cars can have. There's other companies like Aurora that are working in retirement communities that have less craziness and are, sort of a little bit closed off. So you can have the self-driving cars
In
helping
gated
out.
communities, yeah.
Exactly, gated communities. So more than likely we'll see this sort of slow deployment in little closed off sections in major cities. And then over time, over the next 10, 20 years, it will increasingly work anywhere.
Okay. Well, let's get back to your focus. So as you're doing this, what has been your breakthrough achievement where you were just like, I can't believe I was able to do this. Oh, I'm so excited about this.
Well,
I know it's probably mundane, like some little thing, but it was a big movement.
Let's see. So we've had some pretty cool projects so far. I've been very lucky to join a great lab and have great collaborators.
Okay. So what's an example of a cool project?
Right.
Because they're all kind of cool. I mean, they build those robots that destroy each other, and then,
I wish we had all research projects that fun, destroying each other. So one thing we did in my lab was get robots to learn to use tools. Okay. So as I've explained, part of the problem I've been tackling is knowing how to pick objects up. But most of the progress so far has been this sort of purposeless grasping. So you just want to pick it up. Okay. But what if you want to pick it up and then use it for something, right? Yeah. So if you want to use a hammer, you would not pick it up by the head because you can't then hammer anything, right?
Correct.
And what if you don't have a hammer nearby? So we as people would be very good at just finding something roughly hammer shaped and then just knowing how to use it.
But a machine might pick up the baby and go, oh, maybe we could use that.
Hopefully not. Yeah.
Well, my machine would, because I'm not a very good programmer, but go on.
Yeah, we'll try to take care of that.
Okay.
So the idea would be to partially be able to decide what is a good hammer-like object. Not a baby, apparently. Yeah.
But a brick or a...
Yeah.
Okay.
Yeah. And then also how to pick it up and then how to actually use it to accomplish the goal.
Yeah. How much force to apply to hammering a nail in versus loosening something.
Yeah. Where to move the tool and then how to use it. So that's an ongoing project. And it's very exciting to try and tackle it because it's still kind of wide open. So you're still taking baby steps towards even stuff like that.
So when you are working on a project, I'm assuming that there are sometimes like things that happen that you just weren't expecting, that everyone sort of stops and goes, what was that? So what would you say in your work has been you're going along and suddenly you're like, oh, we didn't even think of that?
Well, usually in my work, it is when robots hit things unexpectedly.
Okay.
Yeah, we've had some robots hit walls, which isn't fun.
Well, at least they don't hit people.
Yeah, well, we try. We try to avoid that. In general, I think it's usually when things finally work. So
okay.
In programming and engineering and research, you learn to be a little cynical and to like, the magical moment I would say is when something works on the first try.
How often does that happen? Have you ever had it happen to you?
I think I've had it happen once or twice.
Were you just like, I can't believe it?
I was just like, no way. This is impossible.
And were you able to replicate it?
Well, yeah. I mean,
like it worked and it continued to work.
Because we work with code, so usually if it works, it keeps working.
Okay.
That's the other flip of a coin, is when it suddenly stops working for no reason.
Yeah.
Which also happens.
Yeah.
Yeah, that is when it's like there's a ghost in the computer suddenly, and it's a little freaky. But eventually you figure out something caused it.
Yeah. But see, for me, that is the crux of the limitations of artificial intelligence, is that, no matter what, like everything works great, and then suddenly for some reason it's not, and you have no idea. And all the time you saved, it just gets swallowed up trying to figure out why this, whatever it is, your laptop or, whatever it is, doesn't work.
Yep.
And I think a lot of times when people are talking about artificial intelligence and the boon it will have to mankind, they forget that people have technology that consistently crashes.
Yep.
So how do you then realistically talk to people about the realistic expectations of artificial intelligence? How do you counter that, pie in the sky versus it's never going to work and planes are going to fall out of the sky?
I think the best way to understand kind of a reasonable understanding of AI is to think of AI as part of computing, as in the tradition of computing. So we've had computer programs, we've had phones, whatever, and we know that they're not very smart, right? We know that they do kind of what we tell them to. And then they are not very capable of just going off and helping us out. AI allows us to go a little bit beyond that, add a little bit of human-like intelligence, but not much. So any AI technology that we are developing now is still ultimately going to end up in a program that a human launches, a human writes and codes, and the inputs are going to be set by us, the outputs, it's going to be part of a much larger kind of system where the AI algorithm is just a part of it. So I think you should understand AI as not much more intelligent than the email app or the calendar app or the Lyft app in your phone.
Okay. So you talk about humans being the ones who program everything, but aren't there algorithms that humans don't understand that are starting to make stuff that works, but people don't know why because it's the computers that are doing it?
Right. So some of this stuff like speech recognition, like understanding what's in images, there we use these things called neural nets, which discover patterns in lots of data. And they basically map an input, like some audio, to an output, like what you said. And so we don't necessarily understand the complete logic of how that mapping happens because it's just discovered via much of data. We are working, so it's active research to work on neural net interpretability. So you can actually investigate, why did this input cause this output? But I guess part of the point is we are working on the interpretability question. And the second part is these kind of hard to understand neural nets are just part of the picture. So we understand kind of the wrapper around them where we give them this audio in a particular way and we expect them to produce this particular type of output like text. So I think we understand a lot of what's going on, even if a neural net is a little bit mysterious.
Okay. All right. So we just have a few more minutes. I could talk to you for the whole hour, but we only have a few minutes. So I want to make sure that we talk about your favorite project that you're working on. And then also, if people wanted to find out more, if people wanted to pick your brain about stuff, like how would they do that? So let's start with your favorite project right now.
Right now, I'm very excited about something we are just starting out on, which is benchmarking for robotics. So
what is benchmarking
yes,
robotics?
So in AI research, we try to compare newer algorithms to older algorithms, new ideas to prior ideas, but just basically seeing how well they do on some task.
Okay.
And turns out that's pretty hard for robotics, because we need to actually have robots do stuff in the real world. So it's not like a lot of our AI where you can just run a program on a computer and see what the number is. In robotics, it's much harder. So
because it's in the physical world.
In the physical world, yes. So we need to do physical experiments. And so I'm very excited about kind of taking some ideas from traditional science, from physics, kind of where they have physical experiments, right, for centuries. And bringing that to robotics. I think that's going to be my next big project.
Ooh, okay. And so if people wanted to kind of follow what you were doing, or do you ever give talks about what you do? Or?
Yeah, sometimes. I've given a talk recently called How Impressive Are Recent AI Achievements Really? And I try to make this stuff accessible through SkynetToday.com, and they can look me up on Twitter, Andrei Krankov. I post various links to interesting articles and so on. Okay.
And if just in the last minute, what would you say if people wanted to get sort of a good overview, like a firm foundation? Is there any place, is there any website or book that you would recommend people go to learn more about artificial intelligence?
Artificial intelligence.
Or even just your subset of it.
I would say probably, honestly, Skynet Today covers kind of current news and what's going on. So it's a good way to look at understanding current events and AI.
So say that again.
So SkynetToday.com.
SkynetToday.com.
Yep.
Well, Andrei Kordenkov, I want to thank you so much for being on the show today and making artificial intelligence accessible, because I thought that was fantastic.
Great. Thank you for having me.
Okay. People of Earth, you can learn about computers. There are people who actually go out of their way to make things understandable. Artificial intelligence is like anything else. And it's like there are people who are working hard at it. There are people who have pie in the sky version of it. There are people who have the sky is falling. And then there's the middle ground where it works in these instances and they're still working it in others. So right now we don't have to worry about it so much because it's not in the horizon. What we should have to worry about is the vote, which is going to be coming up soon. So we're going to be having some people from the Department of Elections here in San Francisco come in and talk about voting. So until then, let's listen to some Cab Calloway. This is Everybody